Welcome to our PBL Solar Power On heat analysis tutorial. Hello everyone. Here we have the tutorial for RF heat analysis in this project. Now, the steps that we will follow: first, we are going to get the specific heat according to the food you used on your solar oven. In slide number 3, we are going to choose the mass according to the food and amount used for your solar oven. And in step number 3, we're going to go to slide number 4 and choose the initial and final temperature according to the type of solar oven. Then we are going to do the heat analysis of model 1 and the heat analysis of model 2. Remember that this situation is because we are in quarantine, meaning we are at home and many of us don't have means to get either the mass, get initial final temperature. So that's why this tutorial is very helpful. Now, the formula bank that is in the left, you can see formulas, for example, unit conversions, the main formula for heat, derived formulas, and conversions of temperature from Celsius to Kelvin and vice versa. Now, let's go to step number 1, specific heat. Choosing the specific heat will be according to the food that you chose for your solar oven. An example, if you choose a chocolate bar similar to this one, this will be your specific heat with these units: joules over kilograms degrees Kelvin. The same for marshmallow, Oreo cookies, hot dog or sausage or similar, pizza slice or sandwich or similar, chicken egg or similar, and finally any other type of food. Now, choosing the mass of the sample that you used. Back again, it will depend on the food that you chose, plus if you chose a big amount or a small amount. In the chocolate bar, big means the whole bar, small means just a piece of it. For marshmallows, if you use the big ones or if you use the small ones. If you use several of them, just multiply it. Suppose that you use 3 of these ones, times 3, that will be 9 grams. Oreo cookies, the same. Big are the normal ones, the small ones are the mini Oreos. Hot dogs, back again, the big is the normal one, and if you just use a piece of it, this is the amount that you will use. For pizza or sandwich or similar, is if you use the whole piece of it, you use this mass, and if you use just a half of it or a small piece, this small mass. For the chicken egg, the big ones are jumbo, and the normals are usually the ones that they sell at the supermarket. And if you have any other type of food, if you have a handful, you will use this mass, or just a small piece, this mass. Check it out, all the mass are in grams, and according to the specific heat that is in kilograms, probably you will need a conversion over there. The next that you're going to get is the temperature for models 1 and 2. The temperature will be determined by the food that you chose and the type of solar oven that you have made. So, for example, if you use a box or a pizza box, this is the column for it. If you use a box or a pizza box with a special feature, you will use these ones. A parabolic solar oven, these ones. And if you use a parabolic solar oven with a special feature, you use this one. If you have a very different type from these 4, use this column, any other type, and according to the food. Now, with this information, you're going to calculate the heat analysis for model 1 and the heat analysis for model 2. Now, let me give you an example. Suppose that this is my solar oven and I used a bar of chocolate. Now, I go to slide number 2 and I select chocolate, and the CP is 1600 joules kilograms degrees Kelvin. For mass, as I'm using the whole bar, I use 45 grams. And finally, for temperature, as I have a pizza box with a special feature and I use chocolate, these are my initial and final temperatures in degrees Celsius. So back again, be careful in here. Our CP is in kilograms degrees Kelvin and the temperatures are in Celsius. So probably you will need a conversion. Now let's continue with my example. The first thing, as the first box says, is to write down the heat formula. From the first page, I copy the formula, that is Q equals mass times specific heat, CP, times the difference in temperatures. Step number 2, get the specific heat. I already got it, because it's chocolate, 1600 joules, kilograms, degrees Kelvin, I just copy it. Step number 3, get the mass from slide number 3. So the mass, because I'm using the whole bar, 45 grams, and immediately I divide it by 1000 to convert it to kilograms. Step number 4, get initial temperature. As this is my solar oven and I use chocolate, initial temperature is 20 Celsius. And because I need it in Kelvin according to the specific heat, I immediately copy the formula for conversion. It's just adding 273 and I got 293. Final temperature is the next one, is 48, and back again I do the same. I just add 273 and that gives me 321. Then we had to substitute in the original formula all the data that we have. And so Q, that is heat, equals 0.45 times 1600 times the subtraction of 321 minus 293. Solving the parentheses is 28 and multiplying all this is 2016. Last step is show final answer of heat with units. So heat will be 2016, and because heat and energy is energy, so that will be joules. So this is model 1. I'll then go to model 2 and do the same procedure. I will do exactly the same. Okay, when I finish, I have the 2 heats, one for each model, and I will make a bar graph showing the comparison of both heats. In your bar graph, remember to add the units of your heat. That's it for today. See you soon.